Hello, everyone. This is Professor Ma, and this is the show lectures sign charts. And actually, the two sections of PowerPoints, then the sign chart of factorable formulas. Um, we're given a formula, so one of the things we want to do is find out when the outcome is zero, when the outcome is positive or negative. Okay, and to track this information, what we're going to do is we're going to create a chart on a line. Or, in other words, we're going to create a one-dimensional graph of the formula on the line. And before we do that, let me remind you for polynomials, how can we check for signs very fast? Because we're going to do a lot of fast sign checkings. Checking for positive sign or negative signs. And so for instance, in these parameters, we want to plug in the number minus half into the formula. And the question is going to be positive or negative that comes out. We don't want to calculate by plugging it in. In particular, we can do this, factor it, and then plug it in, then track each parentheses what the sign is going to be. For the front, it's going to be minus. For the next parentheses, it's going to be minus also. Then I can conclude, oh, product is going to be positive, so the outcome will be positive. If I do that to minus a half, then you can check outcome will come on negative. It's a fast way for checking signs. You can do this for fractional formula too. But remember, we have to factor it first, so we can track the sign of each parentheses. If I want to put in minus 3/2, then I get those signs in which there are 3 negative signs, then the outcome is negative. If I put in minus 1/2, I will have 2 negative signs, and the outcome will be positive. And this we want to track of. We want to keep track of this information in the picture with one-dimensional graph. For instance, here's an example of one-dimensional graph of x minus 1. It's very simple. You do it to then see where it comes from. So here's a line, and first we find out. So the question is about the sign. We're going to sort out the signs, and so the first thing to notice, x minus 1 equal to 0 with x equal to 1. So I'm going to put in x equal to 1 right here. And right here at a point x equal to 1, no signs, because if I put in 1, I get 0. The outcome is not positive nor negative. So where the positive and negatives are, they are out to the sides. So the job for us to determine which is which. Is this plus or minus sign, or this is plus or minus? And we can do that pretty fast. Do this. X equal to 1. We can do this by sampling. That is, we come over here to this side, and I said we pick out x equal to 5, and then say, oh, if I put it x equal to 5, x minus 1 is going to be 4. 1 minus 1 is 4. It's going to be positive. So 5 will produce a plus. It turns out that everybody's plus. That's along with 5 in that segment. Until it gets what x to 1. Remember, this is what the formula 0. And then on the other side, I do the same thing and check it. For instance, if I were to check x equal to 0, again, we call this sampling. We sample 0 and put 0 in for x, and 0 minus 1 is negative 1, and the outcome is negative. So 0 will produce a minus sign for the output, and hence everybody in that segment will be 0. And this is a sign chart. That's how we produced it. Then here's the steps. Let me do another example. This is a second degree one. And basically the steps, if you go by really says, first factor, find out where the zeros are, where the boundary point. Then sample. And sample how? Well, just pick a point in each segment and check for the sign. And remember, it's easier to check signs via the factor. So here's what we did. It's going to sample -2. Check. It's going to be plus. Now we check 0. Then it's going to be minus. Check 5. And that's the sign chart. 12x minus 4x. What comes out positive? What comes out negative? Of course, these points right here, the points in the sample over here, they really just, and they really don't it's not in here for any what I'm trying to say is this -2, and this point is really it's really not part of the chart. On that part, it's all positive. Yeah, here's an example that you can do for fractional form. I'm not going to read it. I do want to point out, in these fractional formulas, we also have to put the zeros where of the denominator where x makes it's going to be undefined. And those are the points over here. These points, they don't produce any signs either. They're not, if you plug in x equal to 1, it doesn't produce a plus or negative outcome because you can't even calculate. So these are exceptional points you have to pick up along with a 0 from the top. So this is a sign chart of a fractional formula. And what do we use these for? Well, we use these to remember to solve second degree, higher degree inequalities. So for instance, if I want to solve this inequality, and the first things I do is I rephrase it into a question, say bigger than 0 or less than 0. In other words, I phrase it into a problem that is corresponds to positive. If I put if the inequality points the other way, then I phrase the problem into a problem of the formula being negative. In this case, we phrase it into the problems rephrase into the problems of these formulas being positive, which is the same problem as that. That's what we're saying. But now, how do we solve these problems being positive? Well, do the sign chart. Do the sign chart of the formula. Here it is. I have to check several points. And then remember, the question is asking for the outcome being positive. That means the parts with the plus sign. That will be the answer. They produce positive outcome. And that's how we solve it. And same thing for fractional formula. In particular, in fractional formula, you are not allowed to multiply across by x, such as like this one, to clear the denominator, and this is highly illegal. So you get x times x is 1. One, and these are x, so you got the answer. And this is just not right. You say why not? I mean, in this answer, x can be -1, right? -1 is less than 1. If I want to take -1 and put it back into this here, the original inequality 1 over -1 doesn't work. So clearing denominator is illegal in fractional inequality. What can we do? Put it into the factor form. What do you mean? Put into one fraction and factor everything. Okay, and that's it. So we change the problem into a negative or 0 problem of this fractional formula factor. And we answer that question by making the sign chart. We make the sign chart. First mark down the points where it's undefined with 0, then we finish the sign chart. Okay. So this is the section on sign chart. Then the next section then is something that to make this process of checking for signs a lot easier. And we're gonna do this for factorable form. Okay. So the motivation is this. Well, I think let's think of the sign chart for the formula f of x equal to x, and of course it's equal to 0 and 0, and this side is positive and this side is negative. Everything x on that side is positive, x to the left negative. Then let's take a look at the formula x squared. But the same thing, it's at 0, 0. And if I take number from positive, it's positive. And here comes the difference. On the negative side, even though it's negative, I'm going to square. So that outcome will be positive again. In other words, for x squared, its sign chart, it's all positive. This 0 is sort of not there. You can just say, oh, it's all positive, except there's a hole for 0. If I look at the formula x to the third power, it's going to be the same as this chart. Positive on the positive side, negative number, third power is negative, so it's negative on that. And but x to the fourth power, it's going to be like back to plus and plus. So with these observations, now I can produce a sign chart very fast. And the ones that we can do, the formulas we are going to do sign chart using these observations are the factorable. What do you mean by factorable? A formula can be factored into x minus something, x minus something. For instance, this formula. First things, if I want to factor is, I can pull the 2 out. So the 2 is this number right here in this this general form. Okay, that's what the number you find. It says, you pull the number out. So of course you're left with x to the 7 power and something, and now we're going to break out the x to 7 powers as x minus something, x minus something, x minus something, x minus something. Of course you have 7 of these parentheses. You have because you're going to get to x to the 7 power, and so this is what factorable polynomials are. A polynomial can be break down into this format. If you break it up into this format, then it's very easy to read out what the roots are, the zeros. Okay, so you got factor, that, and so now the zeros is x equal to 0, x equal to minus 2, x equal to plus 2 from those parentheses. Okay. And so those r's are the roots. Notice it has to be x minus. If it's a plus, you have to write as minus, minus. Okay, it's plus 2. It's going to write as minus, minus 2. And the roots will be 0, minus, and 2. Then for each root, there's a power associated to it. For the 0, there's a power 3. For minus 2, there's a power 2. For the positive 2, there's a power 2 also. Those we call the order or the power. We usually call the orders. Okay. 0 has order 3, minus 2 and 2 has order 2. Okay, here come the theorems. What's interesting about the order is like the example for x, x squared, x cubed, x fourth, is whether it's even or it's odd. And just as the example for x squared, the even order ones, over here, plus and minus 2, they show up twice, even order. they don't, on the sign chart, they don't affect the signs as the sign crosses them. So the different ways, so this is one way to summarize it. Okay. Here. Let me do the sign chart for this. The roots 0, this is odd because all the ratio power 3 came from. Associated with the -2, it came from here. And this is even because it is power 2 and the positive 2. Same thing, it's even. And now do a sign check. For example, check x equal to the 100. There's no doubt, it's very large. So everything inside is positive. So this is positive. Now as it crosses even, what's the sign on the other side? Oh, because it's a square, so it's going to be the same sign. But on the R power, the sign will be different across those points. So this will switch to -7. Now it crosses -2, it's even power. So the sign will be the same on both sides. If they both positive or they both even. Since that's even, so that's even on the side. So this is a sign chart. And so this is an easy way for producing sign chart. Like these ones, the roots, you put on even or odd, and test one number is plus, then the rest of the sign propagates to reveal itself. Crossing 3, it's odd order, so we change the sign. Crossing 0 is an odd order again, it's order 3, so we change the sign. But when it crosses -3, it came from square, so it doesn't change. Okay. And we can use it to solve an inequality problem. So then you can read this. That's it. So do the odd number homeworks and a lot of drawing, process, and minus sign. And this is the one-dimensional pictures of our formulas. And what we're going to do from these one-dimensional pictures, pull the signs into a two-dimensional pictures. Okay. And we're going to graph that's the graph of factorial polynomial. Okay. Okay. Bye bye. Have a good day.